Okay, so this is where most of you are going to jump in and join us with our distance learning with page 2. And this was your homework that you had from our last time that we were together. You're asked to classify polynomials by degree and number of terms, and then you're asked to classify these. Okay, so if you're at home and you don't have the worksheet in front of you, I want you to get a lined piece of paper, and I want you to take a look at all of these, look at each of these, pause the video, and see if you can come up with 2 terms, one from each box, to describe each of these polynomials. So pause the video and go ahead and fill that out. All right, so check it out. As I look at each of these, and I want you to think of it like a secret code, where you're using these words from these 2 boxes to let everybody know more information about these expressions. This is a constant. Constants by themselves can only be monomials. So if you include that, that's fine. If you don't include it, everybody knows that a constant is a one-term expression. This one's linear because I don't see an exponent. It's a monomial because there's one term. Here's a linear because this has an exponent of 1, but a binomial because I see 1, 2 terms. A quadratic because of the 2, trinomial because 1, 2, 3 terms. Cubic because of the 3, binomial because of 1, 2 terms. Quartic because of the 4. Polynomial, 1, 2, 3, 4 terms. I don't have a special word for 4 terms, so I'll just go ahead and use the word polynomial. Okay, so this next section is super important because what we need to be able to do here is put the terms in standard form first. So before I can know what it is I'm dealing with, I need to know what the standard form is. So I have to go through each expression, and my first job is to look at what the highest exponent is. And that coefficient and term comes first. If it's being added, I know it's going to be positive. And I can go ahead and just write those terms here. Notice this one's negative, so I know it's being subtracted, so that's going to make that one negative. When I look at the rest of the polynomial, I see a descending order. Here's a 1x, here's no x's. Next comes my 2 x's, which is x squared, minus my x plus my 64. And make sure you know that this minus x is going to, that sign carries over. This one is my 5x squared is a good next term, but that linear term and then the constant have to come next. I don't have a quadratic term, just a linear term here and a constant of 24. So now that I have them in standard form, if I wanted to, I could say that's a quadratic trinomial, a cubic polynomial, a cubic polynomial, and a cubic trinomial. All right, next section, it says find the sum or difference and make sure your answers are in standard form. We're going to refer to this as just combining like terms. If the like terms are positive, I'm adding. If their signs match, I'm adding. If their signs don't match, I'm subtracting. Because I have an addition sign here, I can go ahead and not worry about distributing that negative. My x squareds are positive. My x's, my linear x's, my 3 of them are negative. And my constant is negative. 1x squared plus 3 more makes 4x squared. Negative 4x's, take away 3 more, makes 7x's that are negative. Positive 3, negative 5 is negative 2. This negative I'm going to distribute to each of my terms. negative 3x squared minus 5x plus 1. Now I can go ahead and combine my like terms. These negative 3x squareds plus these positive 8x squareds are going to be 5x squareds. Negative 12x's minus 5 more. Positive 4, positive 1, positive 5. We'll go ahead and we'll share out minus 3 plus 9x squared plus 2x's. So when I combine my like terms, we want to look for our highest degree first, which is going to be these 7x squareds and these positive 9x squareds, which are going to give me 16x squareds. These positive 2x's, these positive 2x's make positive 4x's. This minus 3 and this minus 3, when combined, give me minus 6. I'm going to go ahead and share out my negative 5x squared minus 4. So now what I have is 7x squared take away 5x squared is going to give me 2x squareds. These 3x's, I don't have any linear terms here, and I don't have any constant terms here. So those forms come together. These two binomials, when I combine like terms, make a trinomial. Okay, we'll turn the page over and take a look at these. I'm adding this polynomial to this polynomial. When it's all addition, these parentheses don't matter. 3x squared plus 4 more x squared make 7x squared. Here's a linear term, no x's there. Here's a constant, plus 3, take away 5. And that's going to be my polynomial after I combine my like terms. All right, do I have any other x cubes? I don't see any. So 5x cubed is my first term. Sometimes I like to cross them off just to keep track. These 2x squared and these 3x squared together give me 5x squared. This minus 1x and this minus 4x's. And I was able to combine those, so I have this 4 and this positive 1 left, giving me 5. All right, so this one's definitely tricky. There's an awful lot of terms here, and I want to be careful that I watch out for my signs, especially this subtraction, which is going to change each of these into addition. So we're just going to take this one step at a time. Let's first look for our 2x squareds. Here's an x squared and here's an x squared. 2 minus 1 plus 4 is going to give me 5x squared. So 2 take away 1 is 1, plus 4 gives me 5. Alright, so now I look at my y squareds. I have 3y squareds here, 1 here, and negative 3 here, which leaves me with just 1. Now I'm going to look at my z's. Take away z squared plus z squared, they're going to be a 0 pair and cancel out. So that's my whole answer. All right, let's take a look at this one. And remember, just take it one at a time. Here's an x cubes, here's some x cubes. Your coefficient tells you how many you have. 8 plus 5 is going to be 13x cubes. Once you use them, cross them off. Now let's look at our x squareds. I have positive 2 here, negative 4 here, which means minus 2x squareds. And I can cross them off. Here, let's take a look at our x's. Positive 3 minus 1. That's going to give me positive 2x's. 3 minus 1 is positive 2. Now I'm going to go ahead and look at all I have left now is my constants. So when I look at my constants, 15 and 12 added together is 27. So I end up with standard form, cubic, quadratic, linear, constant. This is going to be a cubic polynomial. All right, so if you remember our tiles, what we put together last time when we played with them, we had our x's. And remember, our x squareds are because x times x is x squared. Then we have our x's and our constants. Here's an interesting conversation. The shaded ones are negative. So this is going to be minus x squared for each of these problems. And these are going to be minus x. Every time you see a negative, it's going to be a minus. And these are going to be minus 1s. So when we tally up how many we have, these two positive x squareds, take away 1 is going to give me just 1x squared. All right, let's look at our x's. These 3 negatives and these 2 positives is going to leave me with 1 negative x squared. And check it out. These negatives cancel out with each of those positives. So this is my final answer. All right, so if I have 2 negatives, I don't have any positives to cancel out. So we're going to say that I have 2 negative x squareds. This one negative cancels out with this one positive, which is going to give me, remember these are my x's, 2 x's. All right. These 2 negatives cancel out with these 2 positives, which is going to leave me with 1 positive 1. All right, the last problem on the page, which polynomial is represented by this diagram? So if I look at the diagram, I have 1, 2, 3, 4, 5, 6 of these x squared terms. So here's a 6x squared. And here's a 6x squared, so we can cancel out B and D as choices. All right, let's count our x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 x's. And then, of course, here's our 1, 2, 3 pieces together. So here is my polynomial expression for these pieces. All right, good job. Thanks for sticking with me.